Hybrid diesel-electric power systems in partnership with the University of Ottawa and ZEC Wind Power.
Today, many Canadians enjoy access to reliable and affordable electricity. However, this is not a luxury shared by all, such as those in northern communities. These communities are small and geographically isolated from major population centers. For these reasons, connecting northern communities to large-scale electrical grids is not economically viable. This is why over 300 northern communities in Canada rely on diesel generators for their electricity. Unfortunately, diesel-electric power is not the best solution. It is a contributor to social, economic, and environmental problems, such as the burning of diesel produces greenhouse gases and other harmful emissions which contribute to global warming and can negatively affect the local population's health. In addition, diesel generators which have not been properly maintained are susceptible to failure, resulting in community blackouts. This is especially dangerous for northern communities during the winter months when it can get very cold. Finally, the high costs associated with the purchase and transportation of diesel can impact the local economy's ability to grow and prosper. Renewable resources such as wind and solar power have tremendous potential in northern communities as an alternative to diesel. However, there are limitations on these energy sources. Wind power can only operate within a certain range of wind speeds, and solar power relies on the availability of the sun. Alone, these sources are not a suitable alternative to diesel generators. The solution to this dilemma is a hybrid diesel-electric system. Here's how it works. When the sun or wind is available, these two sources provide energy to the system. This energy is used to charge the battery bank. The battery bank will then supply power to the load. When the battery cannot meet the demands of the load, the diesel generator will kick in as a last resort. The control of the system is all facilitated by a charge controller, which is responsible for voltage regulation and conversion. Now to provide additional information on the hybrid system and the importance of collaboration between industry and universities, an industry representative will now present his role in the project.
I consider the collaboration between university and industry extremely important and one of the best ways to get ideas, fresh ideas from fresh talent out into the market. I started out as a university student under Dr. Abash, and I worked on an industry-related project, which eventually turned into this revolutionary wind turbine that we are now working on at ZEC Wind Power. Here at the Brunsfield Center, students from the university are in collaboration with industry and have many projects going which are sponsored by one or more industrial partners, and many of them have market potential. ZEC Wind Power is working with power engineering students to implement its novel wind turbine and controls design into their prototype hybrid system. The ZEC Wind Power turbine has many advantages, from higher annual energy production to lower maintenance costs, and in the end, a larger return on investment. We look forward to working with the power engineering students on their prototype very soon.
The hybrid microgrid system was designed by students from the University of Ottawa and was implemented at ZEC. The prototype is composed of a power supply, an actuator connected to an induction generator to simulate a wind turbine system, a PLC controller, a frequency generator, as well as an adjustable photovoltaic system. Next steps include the integration of a diesel generator and fuel cells. Once it is completed, the prototype will be used as an open-ended test facility for student projects, such as an automated solar tracking system or even a power factor correction system.